This is an applied problem. A rectangle with a diagonal of length 5 times the square root of 5 yards has an area of 22 square yards. Find the dimensions of the rectangle. Well, we'll familiarize ourselves with the problem first. And let's just assign variable names to the dimensions, to the length and to the width. We'll let L equal the length. And let's let W equal the width. And these are going to be in yards. Now let's just make a little drawing of this rectangle. We have a rectangle with length L and width W, and we know that its diagonal has length 5 times the square root of 5 yards. So seeing this drawing shows us that we can use the Pythagorean equation to get one equation in the system of equations that we'll translate to. We have a right triangle here with legs of length L and W and hypotenuse of length 5 times the square root of 5. So let's use the Pythagorean equation, and we can say that L squared plus W squared is equal to 5 times the square root of 5 squared. Or we can write this as L squared plus W squared, and when I square this I get 25 times 5, so that's equal to 125. And we also are told that the area is 22 square yards, and we know that the area of a rectangle with length L and width W is the product of the length and the width, L times W. So we know that L times W is equal to 22. So we have this system of equations, and let's go ahead and solve that. I'm going to use the substitution method to solve this system of equations, and the first thing that I'm going to do is solve the second equation either for L or for W, and then substitute into the first equation. And let's just choose to solve it for L. If I divide both sides by W, I get that L is equal to 22 over W. So I'm going to substitute this for L in the first equation. I have 22 over W squared plus W squared is equal to 125. And when I square this, I get 484 over W squared plus W squared is equal to 125. Now, if I multiply both sides of this equation by W squared, I eliminate the fraction here. I clear the denominator. And I would have then 484. I'm multiplying W squared by W squared, which is W to the 4th power. And I also have 125 times W squared. Let's write this equation now with 0 on one side. I'm going to subtract 125 W squared on both sides, and I'm just going to rearrange the terms so that I have the term of highest degree written first. So I would have W to the 4th power minus 125 W squared plus 484 is equal to 0. Now, this is a 4th degree equation, but it's quadratic in form. It's in the form of a quadratic equation. So let's just proceed to solve it. Now remember, the equation is W to the 4th power minus 125 W squared plus 484 equals 0. And let's let U be equal to W squared. Then U squared is going to be equal to W to the 4th power. So we'll make those substitutions in our equation, and we'll have U squared minus 125U plus 484 equals 0. And I can factor on the left-hand side. I have U minus 121 times U minus 4 equals 0. Now if I solve U minus 121 equals 0, I get U equals 121. And if I solve U minus 4 equals 0, I get U equals 4. But now remember, U is equal to W squared, so let's substitute W squared back for U. W squared equals 121, or W squared equals 4. And when I take square roots here, I get W is equal to plus or minus 11, or W is equal to plus or minus 2. So the next thing that we need to do is to check these possible solutions in the original problem. And remember, we're checking W equals plus or minus 11 and W equals plus or minus 2. Now, I can eliminate the negative possibilities because these numbers are supposed to represent the width of a rectangle and they can't be negative. So we'll check 11 and we'll check 2. Remember that originally we had an equation that we solved for L, and we got L is equal to 22 over W. So if W is equal to 11, then L is equal to 22 over 11, or 2. And if W is equal to 2, then L is equal to 22 over 2, or 11. And you can see that in either case we're getting 2 and 11. And this tells us that the dimensions of this room will be 2 yards by 11 yards. And since we usually consider length to be longer than width, let's let L be 11 and let's let W be 2. Now we need to check these dimensions. Remember that the diagonal of the room was 5 times the square root of 5 yards. So we need to know if 11 squared plus 2 squared is equal to 5 times the square root of 5 squared. This is 121 plus 4, which is 125, and that is equal to 5 times the square root of 5 squared. So that checks. And the other thing that we need to check is to see if we have the correct area with these dimensions. The area of this room is going to be 11 times 2, which is 22, and that was the area that we were given, 22 square yards. So these dimensions do check, and now we're ready to state the result. The length is 11 yards, and the width is 2 yards.